In this video, we will learn how to determine the molar mass of any formula. What you will need is a periodic table and a calculator. You do not want to try to do this without a periodic table and calculator. So what we'll do is, on this first one, we've got sodium bromide. So what I'll do is I'll slide over to my periodic table and I'll get the average atomic mass of sodium. And when I look at the periodic table, the number below each element will be the average atomic mass. So if I find sodium, sodium is 22.99. So I'll say 22.99. And if I go over and I find bromine, bromine is 79.90. And I will just add those up, and using my calculator, which I have here, that number is 102.89. And the units of molar mass will be grams per mole. A mole of something is just how we're going to measure compounds so that we don't have to measure each individual atom, because those numbers get so large. So 1 mole is equal to 6.02 times 10 to the 23rd particles, and those could be atoms, formula units, or molecules. And this unit, unit 8, will have a lot of those conversions. Okay, now let's look at number 2. We've got lead 2 sulfate. So if I look at my periodic table, Pb is 207.20. Sulfur is 32.06. And then oxygen, if you look at the periodic table, oxygen will be 16.00. But I don't just have one oxygen, I have 4 oxygen. So what I want to make sure I do is that I take that into account by making sure I multiply 16 by 4. And when I plug this in on my calculator, I get 303.26 grams per mole. Okay, let's look at number 3, calcium hydroxide. Calcium will be 40.08. Oxygen is 16.00, but you have to think, how many oxygens do I have here? That 2 distributes to oxygen, so I really have 2 oxygens, and I also have 2 hydrogens. Now, hydrogen, if I go back to my periodic table, most elements on the periodic table that we will use here, their masses or their average atomic mass go out to the hundredths place. And that makes it very nice with significant figures that for our masses, if we can just go out to the hundredths place, that just saves us a little bit of hassle when we find our molar masses. So if I find hydrogen here, that's element number 1, I'm going to say hydrogen, instead of it being 1.008, I'm going to call it 1.01. That way, hydrogen goes out to the hundredths, and my life is made a lot easier. Okay, so I'm going to make this 2 times 1.01, and when I add those together, I'm going to get 74.10 grams per mole. Another example here, I've got sodium. So sodium will be 3 times 22.99 according to the periodic table, plus phosphorus. Phosphorus is just 30.97, and I only have 1 phosphorus atom. And then oxygen, I've got 4 of them, so again, I'm going to do 4 times 16. And just for significant figure reasons, I'm going to make it 16.00. I always think it's best practice that you do include those 0.00 for the decimals. And this will be 163.94 grams per mole. On something like ammonium carbonate, the first thing we have to do is we have to be able to get that formula. And so ammonium, that is NH4, with a +1 charge. Carbonate is CO3 with a 2- charge. So what we'll do is we'll say, okay, I need these guys to cancel each other out. So I need 2 ammoniums, and so this will be NH4, and then 2 of them outside the parentheses, CO3, and then now I can go through and get my molar mass. A lot of these molar masses over time you'll just know. So I know that nitrogen is 14.01. I know hydrogen is 1.01. But I've got 8 hydrogens, because 2 times 4 will be 8, so I need to always make sure I get the right number. Plus carbon, which is 12.01. And then I've got 3 oxygens here this time, so plus 3 times 16.00, and those will add up to be 96.11 grams per mole. And that is how you do molar mass.